Good day, Viasato. Today we want to look at another question from Becker past question. Let's see the question on the board. This is a right angle triangle. How do you know that this is a right angle triangle? Because of this angle here. This is a right angle triangle. The question says we should find the value of this y. This is a past question for 2022. We are asked to find the value of y. The first we are going to do is we are going to look at this angle. This is the angle given to us. So this angle we have three sizes: 1, 2, 3. Now we are going to look at the position of those sizes to this angle. Let's look at this one, and this is 30 degrees. This side is the opposite because it's facing this 30 degrees. So this side is opposite. Then any side that is facing this one, this is right angle triangle. This is mark of right angle triangle. Any side that is facing this right angle is called the hypotenuse and is the longest side. So this is my hypotenuse. This is where this angle, this side is facing this angle. So this one is opposite, and the last one is adjacent. Now, if you look at the question very well, we are given angle and we are asked to find the side. So what are we going to use for this one? We normally use what we call SOHCAHTOA here. We have SOHCAHTOA. Anytime we are given right angle triangle that involve angle and side, so what we normally use as our formula is we call it SOHCAHTOA. Then what is the meaning of SOHCAHTOA? The first one is sine equals to opposite over hypotenuse. That is the first one. The second one, that is cos equals to adjacent over hypotenuse. Then the last one, this is tan equals to opposite all over adjacent. So this is what we mean by this is SOHCAHTOA. Now look at what we are given now. Anyone that has all the quality, this is what I'm saying. Look at this one. This one is hypotenuse. That means for this angle now, I'm going to make use of this hypotenuse and opposite and hypotenuse. So for this, I'm going to use opposite and hypotenuse. So out of this one, out of these three formulas that we have here, I'm going to look at the one that contain opposite and hypotenuse together. Let's look at it now. We have sine, opposite and hypotenuse. This one is adjacent. This is one opposite and adjacent. So the only one that contains what we are looking for, which is opposite and hypotenuse, is sine. Opposite and hypotenuse. So that means I'm using sine to calculate this one now. So I'm using sine. What is the formula for sine? Sine theta equals to opposite over hypotenuse. Now for me to substitute, what is our theta? Theta is the angle that is given here. So I'm going to have sine 30 degrees equals to, what is our opposite here? That is unknown, y. Then hypotenuse. What is my hypotenuse here? Is 10. Now to calculate the value of y, I'm going to do what? I'm going to cross multiply here. So I'm going to have sine 30 times 10 equals to the y that I'm looking for. Now sine 30, how can I get sine 30? I can only get sine 30 from my textbook or four-figure table. So if you are using your textbook, we are going to check at the back of the textbook. When you open the math textbook like this, there is a page that we have sine of angles written on it. So under the sine of angle, we are going to trace it down to where you have x. That is the first column. So I'm going to check 30 degrees. So if I'm going to check my sine, this is sine of angles, then I will trace the first column to get my 30. Under here, my 30 here is 0.5. That means the value of sine 30 is 0.5. So instead of writing sine 30, I will substitute the value, which is 0.5. So I'm going to have 0.5 times 10 equals to y. So 0.5 times 10 will give me what? So that is my y equals to 0.5 times 10, that is 5. That is 5 meters. So the y that I'm looking for here is 5 meters. So let's meet in another class where I will be taking another Becker question.